Hello, thank you for willing to participate in our virtual reality experiment. The purpose of this experiment is to learn whether virtual reality can introduce mental model for systems. This short video will prepare you for understanding what systems and what systems elements are. We build systems in order to serve certain purposes. For example, our HVAC systems provide air conditioning by pushing air and cooling it and reducing humidity. Our braking systems in our car provides hydraulic fluids in order to push the brakes and slow the car. For the second, this beautiful scenery when we have a lake and we have a tank and we would like to provide water from the lake to the tank in order to provide drinking water for a local community. To derive water from the lake into the tank, we need to have a pump. And pump is a device that pushes water from one direction to a different direction by creating pressure. Once we have a pump, we need to have a piping system that will allow the pump to suck water from the lake. As we can see, the piping systems in the image now consist of some straight lines and some elbows. This 90 degrees elbows allows change direction with the pipes. These elbows can be in multiple angles, 30 degrees, 45 degrees, and so on, in order to serve a change direction in the pipes as needed. Since we are pumping water from a lake that is probably not clean, we need to have a filtration system. So we add a filter in the piping system that goes from the lake to the tank. Obviously, we need to put the pump and the filters. We add another piece of pipe. Finally, a valve, and the valve connects between the filter and the tank. The purpose of the valve is to shut off water flow from the pump into the tank, or for example, if we need to replace filter, it provides from emptying the water by gravity because the valve is closed and do not allow water to flow. We use off valves quite often in order to isolate segments of the systems in order to provide maintenance service and so on. So valves are quite common, and there are multiple types of valves, as we will see very soon. Just a note here, a pump that we use in order to transfer water and most of fluids are known as centrifugal pumps, and these pumps suck water through the center and accelerate them and shoot them out from the pump from the outside. So this is the configuration of a centrifugal pump in a system. Again, water inlet is through the center of the pump, and the water going outside from the external side of the casing. Now let's review certain elements that are typical to system that you can see in the virtual reality experiment. The manual valve that we saw before will appear in the virtual reality as the image describes here. The symbol in a 2D system presentation will be as what we see in the right column. For each one of these elements, the functionality of the valve is described in the columns called functionality, and the title of the valve and any other item will be on the left item. Upon completing this segment and starting the simulation, you'll get handouts with all of these valves and items, and these will be available in the virtual reality environment as well. So now we looked at this manual valve that by hand we can change direction and prevent flow or allow flow through the piping system. Another type of valve will be a motorized valve. In a motorized valve, instead of human power to operate and close and open the valve, we use motors. We use motors sometimes when it's really hard to get to a setting, or when there are some hazards associated in the environment, and having a motorized valve prevent exposing people to this hazard. These motorized valves are usually operated by electricity. In some instances, we would use what is known as a solenoid valve. Solenoid valve either shuts, close, or open the valve. Motorized valves and manual valves allow us to partially close or partially open the valve. Solenoid valves can be operated by air pressure or by electricity as well. They're known as solenoid valve, and the column on the right describes the difference between motor valves, solenoid valve, and manual valve. Another type of valve is known as solenoid valve that is also manual, which allows us to open or close the valve manually in case the solenoid is not working. This is also common in the industry. Another type of valve is known as pressure regulated valve. In this type of valve, there is an element on the line that measures the pressure, and based on the pressure, we either open or close the valve in order to adjust the pressure in the valve to a preset up pressure that we want to be at. This helps either in preventing or too much high pressure because of some elements downstream, or preventing some break of equipment because of overpressure. So pressure valve that is connected with the line as described in this image are common in the industry as well. Another type of valve is known as relief valves. Relief valves are usually used when the pressure is really high and there is a concern that the level of pressure will damage the equipment or lead to rupture of equipment or piping systems. For example, in steam pipes, steams are used to heating the university buildings. Steam can go up till 500 pressure, which means 500 bars, 500 kilograms per square centimeter. That's enormous pressure. A spring which is connected to the valve apply pressure into a setting, and when the pressure in the piping goes above the power that the spring can create, the pressure is being relieved to the atmosphere. These are known as relief valves, and we always use them when we use high pressure fluids that are compressible, like high pressure steam, high pressure air, and so on. So these are relief valves. One other type of valve is known as check valves. Check valves allow flow in certain direction but do not allow flow in the opposite direction. So check valves are working in case, for example, that we have pumps that push water against the resistance, and in case the pump fails or stops without any control, the check valves prevent flow of the water from the opposite direction into the pumps. So these are known as check valves. They're pretty much one direction allowing device on a piping system. Flow restrictors is another type of a device. Flow restrictor will allow to a certain level of flow to go through the pipe. These are mechanical devices in most of the cases, and when as much as the pressure will increase at one side of the flow restrictor, the flow restrictor will prevent the flow going above a certain direction. So when we need to have a certain flow and we don't want to get into a case where the flow will increase above a certain level, that's what we use. For example, our propane tanks have a flow restrictor in them. In case of a rupture of a hose that connects to the propane tank, there is a flow restrictor that will not allow for too much of a flow of gas into the air because of this rupture of the hose. And sometimes we need to connect between valves, and connection can be either welding, can be connection that are made with bolts, and sometimes the connections are just very fast connections. This is very common in mechanics auto shops. When you go there, you can see that they're connecting air pressure hoses one to another with a simple fast connections. These are quite common. Sometimes you will see that a truck that provides fuel to gas stations is staying just on top of the tanks and connected to the fast connection. That's another example of how to use fast connection in order to for temporarily providing fluids from one storage to another. Another element that is used quite often in piping is a pressure transducer. When we need to know what the pressure is, or when we use the pressure in order to create another sequence in the process, for example, a computer will measure the pressure, and based on that will decide whether to start providing fluids to a reactor or not. Then we use a pressure transducer. Again, a pressure transducer may just present the pressure, or it can be used in order to deliver commands for a pre-set up system. Similar to the pressure transducer, we can use temperature transducer, who just do just the same thing. For example, if we have a pressure transducer that needs to control the temperature in a reactor or in a tank, then the pressure transducer will measure the temperature, and if the temperature is too high, it will shut the flow of hot water into the system. If it's too low, it may increase the flow of hot water in the system. Again, temperature transducer like pressure transducer can be used just to show the temperature, or could deliver information into a computer setting that controls the system. And obviously, as we saw in the example at the beginning, we use piping systems in order to connect between elements of systems. As we can see here, we mentioned we have a 90% elbows, we may have a 30% elbows as well, and this allows to change direction in the piping system. A diffuser is a device that mainly used in providing airflow. A diffuser gets air that comes from a duct and makes sure that it will spread nicely in the air around and will not hit directly when in the direction of the pipe. So air diffusers are very common in HVAC system, and if you look around you, you can find them in the ceilings most commonly. We talked about the filter. A filter has an element that catches particulates from fluids, and by that prevent water that are not clean to go from one side of it to the other side. Water filters usually need to be isolated with valves from both sides in order to periodically replace the element in order to prevent overfilling and clogging of the filter itself. And when the filter gets clogged, it reduces the flow of fluids through it. The two elements that can be used quite often are oxygen monitor. For example, oxygen monitors are being used in HVAC systems that are completely closed. For example, mining operations will have oxygen monitor system to make sure that the appropriate concentration of oxygen is there. Space operations are using oxygen monitoring as well. Similarly to that, carbon dioxide is a problematic gas. While we breathe it in and out, if it goes about 1.5%, there is a concern, the sense of euphoria that comes in, and in some cases will go 3%. It becomes extremely toxic and dangerous. So monitors of oxygen and carbon dioxide usually are connected to alarms, and the alarm will go off when the concentrations go above or below predetermined threshold. And we talked about the pump and covered that. This is the way a pump looks on the 2D scan, and we saw the pump in the example at the beginning. Other elements that you'll not find as often, electrical switches allow us to either start the pump or close the pump or shut off a pump by providing electricity to it. Computer monitors are being symbolized in these two columns on the right. And sometimes when we need to connect between instrumentations, let's say the pressure transducer and a certain other element in the system, we pull wires. Wires are indicated by dashed lines in the virtual reality as well as in the in 2D components. Heat exchanger is another element that is very common. Sometimes when we get fluids that its temperature needs to be increased for the purpose that it needs to be used, or its temperature needs to be decreased, then we use an heat exchanger. Fluid in the heat exchanger gets into one side of it and lives in the other side, and another fluid goes on the shell outside of the fluid that needs to be controlled and cool it. For example, imagine a power station that sits very close to the ocean. So if the power station generates quite a bit of heat because it burns coals, and we need to cool the water, so the water needs to be cooled in the power plant will flow through the heat exchanger, and the heat exchanger consists of a lot of small pipes in there, and what we do is we just get water from the ocean and pump them externally to the pipes in the heat exchanger, and by that we will cool the water that needs to be controlled. Tank, as we noticed, is the reservoir of water that is being used in order to get quite large quantities of water or any other fluids in a certain location. One very important element is cooling towers. Cooling towers are used when there is a need to cool fluids in quite high quantities. For example, power plants that generate power still have quite a bit of heat in their system. These systems needs to be cooled down. What we do is we push water through a system that has a fan and let them evaporate. The evaporation reduces the heat, and then the water are cooled and can flow back into the system after they're cooled. The cooling towers are much more effective than heat exchanger because evaporation is an effective tool for cooling. However, when we evaporate, it will lose the fluid as well. Something to consider. Thank you for listening to this presentation, and I hope you'll enjoy the simulation and in the virtual reality. Please do your best there. This is really critical for us because based on your results, we will design a system to help educate engineers and technicians. Thank you.